When working with customers, we see a wide variety of mixing equipment. We see a lot of benefits or even sometimes issues being caused by the selection of that equipment. I think the easiest place to start is the different levels of mixing equipment that when we're onboarding or interacting with customers or doing site visits that we end up seeing. And I've kind of broken it out into 4 different levels of mixing equipment, starting at probably the more simple and getting to more sophisticated or more automated. Those levels mixing probably start with almost what everyone's experienced in a facility, which is just a barrel or a drum, somewhere probably between 30 gallons and more than likely 50 or 55 gallon capacity. At that point, most people are just using some sort of corded drill, double-handed paint mixer, or a battery mixer, something smaller, cordless, 20 volt or something along those lines. The issue there is with a lot of those smaller drills, there's plastic internals. So you're going to burn them out really quickly and you're going to go through them. When you start talking about $200-300 a drill, you probably could have invested out of the beginning on something slightly nicer. But yeah, if that's going to be the option of mixing in a 50-gallon drum, the preferred mixing that we'd like to see at that point is either something similar to a double-handed corded paint mixer or cement mixer. A little bit slower, but once you find the right head that goes on it, it'll whip the solution pretty vigorously and mix it for you. The other issue I think that comes out of mixing simply in a barrel and having to hold something is the difficulty of it. When you really clock out 5 minutes and then trying to whip a solution that's several hundred pounds between the fertilizer and the water weight, it's actually quite strenuous. What we see between the difficulty and the mixing equipment choices then adequate mixing. Okay, did I really just spend 5 minutes mixing several hundred pounds of solution with this battery drill or this really simplistic corded drill? And even doing that with the double-handed cement or paint mixer is quite difficult. And so I think that kind of brings us to the next level of mixing, or the second level to discuss, is more of a stationary mixer. They actually make them from everything from 5-gallon buckets all the way up to IBC totes. It has a fixed lid or platform that the drill motor or impeller motor is attached to. And then that just rests or simply sits on top of a 5-gallon bucket, preferably a 55-gallon drum. And then on IBC totes, they have the metal basket or perimeter that the tote sits inside of. And on those, it just clamps to the exterior. So a huge advantage there is you don't have to hold it and physically put the effort in to sit there for 5, 10, or 15 minutes and allow to mix it. And in a lot of cases, you can, I don't like to say over mix it, but let it mix for longer than spec'd out to just ensure that whether the water temperature, small differences in quality, or anything is not going to affect the quality of mixing. So I think kind of the second step in mixing equipment and quality of mixing equipment that we see is more of a fixed mixer that just rests and has a platform that the impeller and the motor is fixed to and sits on. Going back to the first mixing methodology, and one other thing that we see that's quite common that can cause some issues is kind of stepping back from having a drill or impeller or some sort of platform. Our pumps or even aero mixers of different brands is they'll churn the solutions, but they do a couple things that aren't real positive, which one is they can add a lot of heat to the solution, which can actually cause the fertilizers to scale or interact kind of negatively with the barrels and the mixing equipment itself. Even the pumps and the motors and the metal internals within those, when they heat up, can be quite negative. And then the pumps, especially on the aero mixer side, the power of the churning and the air being introduced, especially with part B, can cause a tremendous amount of foaming. Almost like seeing a bad cartoon or a movie where the washing machine overflows from too much detergent. You can get a similar effect with the part B and too vigorous of mixing with pump mixers. The other thing too is that long term, they fail. A lot of those motors are lubricated with oils that you don't want to be injecting and putting through plumbing systems or having the plants interact with. Maybe they don't, negatively interact with the fertilizer other than a sheen you don't want to see, but there's other negative recourses downstream from a lot of the internal components of those mixers. The kind of third step in quality of mixers and equipment that we see, or third tier, is probably what people refer to as fertimixers, or another like home built or self built option for that, or cone bottom tanks. You see a lot of people mixing with cone bottom tanks or rectangular Fertimix tanks that sit on the ground. And those tanks then, much like a cone bottom, they pitch and go to a drain point where you can guarantee getting all of the solution out of the tank. And then they usually use pretty high power, high flow rate pumps that then churn and mix the solution really aggressively. Don't introduce too much air, but just keep the fluids moving really, really well and make sure they're homogenized and mixed super, super well. And at that third tier, I think whether that's a cone bottom or more of a square Fertimixing tank, you're kind of in the same category at that point, as long as you have a good pump and good mixing. The next tier that you kind of see above that, the fourth tier, and probably the best out of all of them, is that same cone bottom or square tank. And then you see that motor impeller setup that's stationary and fixed and then dedicated to that tank or that solution being made. Most people don't have tanks and mixers for every single solution, but it's a very stationary mixer, the motor, the impeller, and then it's in addition to the pump and the churning motion. And you see that on cone bottoms and then a lot of the square pitch tanks as well. But that's probably the highest tier and quality of mixer. And really, it's going to guarantee that the solution's homogenized. There's no pockets getting caught in corners or on lips or where there's plumbing fittings. And then also pace of mixing. Although we recommend 3 to 5 minutes or 5 to 15 minutes, depending on the component or the part, you'll notice with that higher tier, it's going to save you a ton of labor, a ton of time, and it's going to solutionize the parts incredibly, incredibly fast. A lot of those systems too, you can set them for periods of time, walk away, and they're going to continuously mix without being monitored as well before you come back and validate those solutions. But yeah, kind of running through those 4 tiers, it starts with a barrel and either a pump or a hand drill. Then your second tier is kind of that same barrel with a fixed impeller and a motor. And then the third tier starts to get into cone bottoms and pumps and recirculation or impregnation systems. And then your fourth tier kind of combines the best of all the worlds, which is a cone bottom or pitched flat tank that uses pumps and impellers to mix.
What's the benefits of tempering your water?
Seasonally, RO water is going to change, and you need to really watch out for cold water as it relates to mixing time and solutionizing your fertilizer. No matter if you have your tier 1 or your tier 4 in terms of the quality and sophistication of mixing, if you have cold water, it's going to drastically increase the difficulty of solutionizing it and the time to solutionize it. On the flip side, though, when you're getting into improving your mixing setup and wanting to make it faster and easier, regardless of what you're using from a barrel to your drill or all the way up to the upper echelon of impregnating with a fixed impeller and motor, something huge to consider is the temperature again of that water. The hotter you can get it, the easier it is going to be to solutionize your concentrates. And I think really the main consideration, or call it even a concern, when you're going to then heat your water up to say 90 or 100 plus, is once it's cooled off, just like the shower head that you take a shower under and seeing that calcium, magnesium deposits, is hot water is going to scale a little bit faster. So either as it cools down or when it cools down, give it a quick spin again and just make sure there's nothing that's scaled. And it'll be mixed, much, much faster with using hot water versus room temperature or even cool water.
What are the most common issues that a facility is likely to see if they're using a mixing method that doesn't match the scale of what they're doing?
I say rushing is number one. They try to make the solutions too fast because they're making them so often. They're frustrated by not having the right equipment. I think frustration then leads to poor mixing. They're just doing it fast, calling it done. And then you have not proper validations or solutionized products. I guess if I'm touching around it a little bit gently, it's just you haven't put all the fertilizer into solution and now you're not going to make the correct recipes and feeds.
I think that's really important for facilities to realize that one of the consequences of not using the right mixing equipment for your setup is that your validations won't line up. And that's why we provide really specific validation numbers in EC per gram per gallon and the standard validation numbers that we can check by taking 250 milliliters from a stock tank, pouring it into 5 gallons of RO water, and then checking that EC. And if you're not mixing properly and there's undissolved salts in your stock tank, then that validation number is not going to come out right and you might be confused. So one of the ways that people can get more consistent nutrient delivery that matches exactly what their feed charts are showing is by making sure that those stock tanks are always getting fully mixed at the start.
The validations are huge there, especially when they're not mixing long enough or properly or using the wrong equipment. Another thought I had stemming from that question was reliance. As the scale of the facility gets larger and larger and larger, some of the things that we do recommend often seem mundane, whether it's the solution testing or what we refer to as bucket testing for different recipes and dialing in the exact pH product you're using if it's outside of what we're recommending. And so what I mean by reliance is then the customers, they'll say, well, I have this beautiful piece of fertigation equipment and I'm just going to go ahead and mix the solution up and I'm going to inject it till it hits the correct value on this piece of equipment. Then as they increase in scale, they're more reliant on the technology without doing the baseline checks and specifications that we're asking for. And it seems too simple, or that there's a piece of technology that they have that can do it for them. And then they rely on it and they get an unexpected result. And then quite often they'll go back and do the titration or just the bench test that we've asked and to set up for that specific recipe or EC. And it's like, okay, well, it was way off in terms of the input value for the equipment, but you just saw with your RO water, your building, you mixed it yourself and measured it all out, that it required that amount at a bench level. Now, okay, this is what you need to set your equipment up at and rely on doing the bench testing versus relying on the equipment.
Well said.